Hello everybody and welcome to Veritone's May 2019 webinar, Exploring Veritone's Object Detection Feature in Relativity. I'm Daniel Wong. I'm going to be your host today, the Director of Channel Marketing here at Veritone. And our special guest is Aaron Adele. He's going to be our AI ML subject matter expert and also serves as a Senior Director of Business Development. Aaron, welcome.
Thanks, guys.
Great.
Glad to be here.
Also joining us later today is going to be Corinna Soto, as some of you guys all know her. She's going to be joining us during the FAQ session to help us answer any Veritone legal channel partner questions you may have. And so she'll be joining us later. So without further ado, we're going to go ahead and move forward with our presentation today. Before we begin, I thought we'd talk a little bit about Veritone so you guys get a better idea who we are. As some of you guys know, we're a publicly founded company since 2014. We have 6 different offices located all around the world, with our corporate headquarters here in Costa Mesa, California, with 380 employees. Veritone is known for developing the world's first operating system for AI, called aiWARE. And that essentially what we do is we transform and analyze assets such as audio and video files, as well as text documents, and turn them into actionable insights, essentially giving you intelligent e-discovery. And we have a proprietary suite of AI applications that essentially turn those insights into value. And we're going to review, and the one we're actually going to review today is our aiWARE for Relativity. And we're going to be talking a little bit about, obviously, the object detection part. So as we talk about aiWARE, and I mentioned to you how we developed an OS for AI, aiWARE, the operating system, is open and extensible, and you can see the operating system with AI reaches out to all sorts of industries out there. And today, where Veritone is very strong in today is media and entertainment, government, and of course, legal and compliance. And obviously, with our operating system that we developed, we have APIs that allow you to develop bespoke applications that solve problems for your particular industry. In our case, Veritone's developed 3 different applications here. Today, we're going to be talking about aiWARE for Relativity, the object detection feature part, of course. We also have another application called Redact and another one for Essentials. In the aiWARE ecosystem, as some of you may know, we have hundreds of AI engines across more than 15 cognitive categories. We manage today over 10,000 AI engine providers and only brought on the best of the best engines onto our ecosystem. Today, we have more than 300 types of engines into the ecosystem, ranging from, again, object recognition all the way down to visual moderation, object character recognition, and so forth. In today, object detection and recognition engines are classified in the computer vision class. We closely have 70 different types of vision-based engines, and object detection engines come in all sorts of flavors. So, Aaron, with object detection, when we say it comes in all sorts of flavors, can you tell us a little bit about what kind of flavors they come in?
Yeah, absolutely. They come in several different flavors, really. And in fact, the term object detection is a little bit of a misnomer, only because there's image recognition, object recognition, image classification. There's different kinds. Usually the rule of thumb is more about what's the use case, how am I applying this technology, and what's going to give me the best outcome in terms of accuracy. And that's when you decide which of these different kinds of technologies apply. But that's our job, and we want to help our customers with that. So we help them guide them to the right technology based on the use case. But we've kind of got the breadth available to cover many, many different kinds of use case.
Great. And as you guys know, we've introduced aiWARE for Relativity a couple of years ago, starting with transcription. And then we started doing redaction within there, and now we've offered a new feature called object detection within Relativity. And so with object detection within Relativity is obviously the use case of being able to cull down video evidence for compliance or court request or discovery requests, if you will, in a very efficient manner. As you guys know, in some of the deal with relativity is in the old days when you used to have an audio and video file, you had to actually pull that audio and video file outside of the relativity and use another software tool to either do transcription or do redaction, again, around audio video, as well as object detection. But what we've done here with Veritone and aiWARE for relativity is we've built the AI cognition into a media player such that the audio and media file stays within the relativity instance, and you'll be able to now do not only transcription and redaction, but now do object detection. And the object detection is really cool. It's essentially turning that on, and once you turn that on, we kick in the AI engines, and they'll start detecting general objects in the file. And as you can see here, it's highlighted. You can see on the display here, there's general object detections we find, such as telephone, and it's all time correlated. So when you press that button where it says telephone, it'll take you right to that second where it's at, which is 39 seconds, and it'll show you how long it runs as well. So some people ask us, well, how do I get started with this? And so it's as easy as in your Relativity media player, once you upload the files, your media file in it, up in the upper right-hand corner, as you can see in the image there, where it says object detection, all you have to do is just click on it. And once you click on it, the object detection engine kicks in, and then it'll go through, it'll process all your media, audio and video media files, and you'll have results pop up on the bottom. So essentially, these are all the generic object detection engines that is supported by our engine here, and you'll be able to find things such as, again, very generic things such as electronics, number, text, and again, if you click on this, it's time correlated and it jumps right to that stuff. So essentially, you're able to now cull down all the generic information you need to find. Now, some people are asking in terms of object detection in our media player. We have aiWARE supports aiWARE for Relativity supports 3 different types of object detection. The first one, the first engine is essentially the default engine in Relativity. It is essentially a general object detection for high-level analysis. So as you saw earlier in the previous screen, those are, again, very high-level generic objects that we're finding, such as a gun or a car or a building or a skyrise, right? That's what we have today as a default engine. We also support a second engine that gives you a little bit more specific, such as a make or model of an object. And that can be done within Relativity, but first, before we do that, we actually have to train that outside of Relativity using another application called Veritone Library. And so upon completion of that in the Veritone Library application, we will then be able to import that engine back into Relativity for customer use. So if you're now looking for more than just a gun, but you're looking for a rifle and maybe even particular an AK-47, we will be able to leverage one of our own engines outside of Relativity, train it, then bring it back into the Relativity instance, so that way you and the customer can use that. The third engine that we do support is, again, it's another highly trainable engine and customizable, where you can now create your own custom library of objects and train those objects around your video files for a specific use case. So what we've done here is we've gone down and refined it a little bit more, where you can not only train that particular gun, if you will, but if you have your own specific video files, we can also train those objects in those video files so you can look for that. And we're going to be showing you some examples on how it gets done. Now, object detection engine number 3 is the same way as engine number 2. This engine is not available within Relativity, but we do it outside of Relativity in one of Veritone's applications, same thing called Library. Once we train that, we can then import that engine back into Relativity for customer use. But the real key important thing about, I guess, out of this whole slide is, in order for us to help you find the best outcomes and the best results, we really want you guys to have a Veritone representative in the discovery loop at all times. And so during your discovery phase, we would love to have you guys engage with your Veritone representative so that Veritone can provide the proper guidance to you and the customer to ensure those best outcomes. So to do a little more deep dive on how object detection works, I'm going to have Aaron talk a little bit about object detection and give you a little bit more behind the scenes on where the magic is. So Aaron?
Yes, thank you. Okay, so as I mentioned before, there are sort of different kinds of technology that can support the different use cases. And I'm going to break it down in these three kinds because I want to kind of give a little more detail on how they apply to different use cases and how they work, and when you would use one versus the other. It's not an exact science, in spite of the name data science. It's almost like a little bit of an art. If you think about how humans learn things and how we recognize things, everyone is different. There's no one exact way to accomplish every kind of use case. So I want to go through the different ones so you get a broader picture. Okay, so starting with image recognition. Image recognition really just means recognizing the entire image. So this is on the right here, an example of that. I've got a photo, and this might be a video, of a traffic scene. And on the right, I have the tags that came out of the engine that we're using, for example, to solve this, which is a pre-trained model with thousands of tags. It's very broad, right? So you see kind of the tags here: lane, highway, road, traffic, freeway, infrastructure. It's looking at the whole image. That's what image recognition means. It's not trying to classify or detect specific things in this image. It's saying, what is the essence of this image? And you can sometimes get tags like black and white, screenshot, moody, foggy, right? They're these sort of holistic image types of situations. And that becomes really useful because in the example you saw earlier, you can search by this. Freeway, waterfalls, trees, right? You can start to get really quickly a very intricate understanding of your media content without having to do any training or anything to that effect. You just simply run the video through, you get these tags, they're searchable, and you can start finding content. And it's pretty good. I mean, it'll say vehicle, it'll say car, even though that is a specific object within this image. It's been trained on images like this with cars in it. So that's why it knows that. So I would say that this is great for search and great for context. This is also trainable. And we actually call it teachable. And I will kind of talk about this kind of segues into image classification, because the difference is, if I have a situation, let's say, where I want to recognize landmarks, right, the Eiffel Tower or specific buildings, I can teach this engine with one example, and it'll learn what that whole image looks like. And the next time it sees images that are similar to it, it'll come up with that custom label, like Eiffel Tower or Building 106 or whatever it ends up being. It has its limits. It's not going to be looking for very specific, subtle differences. It's kind of broader things. Maybe this is a product imagery. With photos, if you've got photos of weapons, you could teach it what kind of different weapons look like, as long as they're sort of roughly the same type of photo. So if we go to the next slide, to image classification, this is where you can get a little more specific. In this example, I actually took a use case that I heard about through the legal and compliance vertical, which I thought was interesting. You're doing a case, maybe somebody fell into a pool and got injured, and you have a security camera in the upper right-hand corner of the outside, or wherever it is, of the area. You've got hundreds and hundreds of hours of footage that you've gotten through this case, maybe through the discovery process. And really, you just need to find the points where the gate was open, the pool gate, or something else was different. Maybe people were present. So I took this concept and used a camera that we have in our office here, actually, and trained it to recognize whether people were detected or not. And I'll go into the details about how I went about that later. But the important is that it's similar to image recognition in that I'm still looking at the whole image, but I can get very specific about the two things I'm comparing. And also with classification, I really only have two options, or three options or four options. And they have to be in one class or the other, right? People detected, not detected. Another example is, gate open, gate closed, daytime, nighttime. I can kind of come up with several classes, but every result has to be in one class or the other. Whereas in the previous engine, they are multi-label classifications. So one result can have multiple labels. That's another key difference. So image classification is when you want to get very specific. But again, we're still looking at the whole image. So the next one, object detection, will help us really kind of drill into detecting specific objects. So this is a similar image to the first one, but this is what object detection does. Let's say you need to count the number of cars that pass by a certain point in a freeway, or the number of airplanes that land in an airport, or the number of products that go by on a conveyor belt of some kind. This is where object detection comes into play. It can essentially scan through an image or video, frame by frame, and look for that specific object and then count it and say, this is where it appears. In the next frame, I see it again, but the next frame, I don't see it. Or in just one frame, how many of this object do I see? So you can kind of see where the lines blur here a little bit, because you can use object detection to solve some of the same use cases as you could with image recognition and image classification. The difference here is A, the use case, and it really depends on the use case, which one you use, but B, the training data required. So if we go to the next slide, I started with two use cases I thought would be relevant that we could talk about. So the first one is that use case earlier, and the way that I trained this was first gathering a wide set of samples. So I got this footage here you see on the right, which is an animated GIF at this point, is an edited together video I put of all the different examples of people walking through this shot at different times of day, different days, night, morning, etc. And I wanted to get a wide set, right? I needed, pretty much any time a real person has walked through this lobby at different times of days. I needed real data. And then I prepared the training data by editing together this video, and then I edited together an equal video of the same camera footage with nobody in it. So any instances where there weren't people, I just threw together these clips, edited together into one sort of piece of footage. Then step 3, I trained and validated it. So I took each one, ran it through our engine that supports this capability. It's called Classification Box, and train the model. So I put all of the examples of people walking through in one folder, all the examples of the people not in another folder, ran the engine. I took out about 20% of the data, didn't train with it, and then used that to validate. And I got about a 97% accuracy. So that means that anytime I show this model a screenshot or a frame from this video, with a 97% accuracy or so, it could tell me whether there were people detected or not. So now I've got, hundreds of hours of recordings from this one camera. I can now quickly go back and say, well, in these sections, people were detected and people were not. I can then, if I'm doing a case, I can know when people are present in a building, time of day, etc. And I can get really detailed there. This is possible, right? So we can upload this model into aiWARE today and run it, and which is what I did. So if we go to the next use case, this one's a little bit different. This one uses object recognition. And it's not too dissimilar. So you can see here what I'm doing is drawing a box around this car. So this is a security footage of a driveway with two cars. And let's say I wanted to know when that specific white car was in the driveway and when it wasn't across, hundreds of hours of footage that I've collected for a case. I can use a tool that we have to annotate a few frames. So what I would do is I would take, 5 or 6 different videos of this shot. You can see there's some garbage bins in the background. I'd want some examples without garbage bins, some examples without a cat. Different times of days, and go through this, draw a few boxes in each one, train the model, and then validate it. So again, I go through a step of seeing what my accuracy is. And assuming it's good, I can then do the same thing. I can upload this model to aiWARE and then run this against all my content. And soon I'll be able to tell across hundreds of hours of video content, when was this car present and when wasn't. And this has other applications as well. We can act on this data, but I think for the e-discovery process, this will really let customers and let us be able to go through untold numbers of hours of video and media content and pull out the moments that matter, pull out the relevant pieces. And what is relevant and what matters is always going to be dependent on the use case and customer specific. And that's why we've worked really hard to enable the training. And we use real customer data to do that. So to kind of recap, we have a generic standard tagging model that will throw up tags that'll let you search and find context. We have a way of doing whole image recognition, and then it's similar to the first tagging, but it lets you get more specific. And then we have a way of doing object detection, so we can actually track and count and keep track of specific objects. I think this might be my last slide, so if there's another slide after this, I might hand it back to you.
Great, thank you. Thanks for sharing that, Aaron. So obviously, as you can see, this is how some of the magic works. And as Aaron mentioned, knowing what your use case is very important. And so as we move down and go to the next slide here, we want to kind of share with you some key qualifying questions that we think you should ask. And one of the first ones is, does the client know what they're looking to identify? And that's very key. And Corinna just stepped in here, and thank you for joining us, Corinna. As you know, Corinna, we're always talking to clients, and sometimes the clients don't know what they're looking for. They just say, I just want object detection, right? And so right. I think knowing what they're looking to identify is going to help us cull down what the goal is, right?
Yeah, exactly. That is correct. So really, at the end of the day, if they have any idea as to what the end goal is, that's always very helpful to be able to know how to provide them with a solution.
Right. The next question we definitely want to know is, are they using object detection as a tool to summarize items in the video without viewing it? And that's going to be, again, very helpful for us to determine whether this is the right engine we're using and what have you.
Yeah, I'll express that a little bit more. So a lot of the times on the legal side or any discovery side, they get a ton of video and it gets dropped on their desk and they have to figure out a way to review it, but they don't know what is even in there, what they're even looking for. So you can use more of a generic engine to kind of quickly summarize what it sees. So you get a quick snapshot of what's going on without actually manually having to see each frame by frame.
Great. The next question is if the client knows exactly what they're looking for, we want to know how specific. So for instance, in here we said, are you looking for a car, which is a generic search, or are you looking for a red car? Mm-hmm. Or are you looking for that, Toyota Camry, which we can go down to very specifics. And as we mentioned before, in the engines and Relativity, it does support the generic car search or the generic search that we would do. But if you want to get to a specific search or a very specific search, contact the Veritone representative like Corinna or what have you, and then we would walk you down to try to understand, what what your goals are, and we would find that specific engine to help you integrate that.
Yeah, and kind of just to piggyback that back all to the qualifying questions, if you can have some of those questions identified or answered in some way, for us, that would help us get a little bit ahead of the game instead of having to go backwards.
Right. Another question we definitely want to ask is, of course, what's the end goal of the client? Because I think that really helps answer everything. Because we could be going down another rabbit hole that we don't want to go down to, right? So, and then finally, what I think this is a great question is, what would help them prove their case, right? Because that's really the nail in the coffin, right? That we're looking for.
Exactly.
So that's kind of the end of our slide. I know there's probably a lot of questions out there that you guys might have based on what you saw today. Feel free to ask any questions you have in the question chat box. We'll be taking some. I see some coming in already. But just so that you guys know, we will be sending out a recording of this to you right after this webinar. You'll get an email with a playback recording. And again, we'll be taking questions right now. So I see a question come in, and it looks like this one might be for Aaron. Aaron, how many images do you need to properly train an image? And And should those images be also of different angles and what have you? So how many images do you need to properly train an image?
Yeah, that's a great question. And unsatisfyingly, I think the answer is it really depends. So in some situations, you can get away with literally one image. Okay, imagine that for a second. Because I know that the part of this process is you've got too much video and you don't want to go through it in the first place. So finding examples of things can be, cumbersome and troublesome. So we do have tools that feature what we call one-shot learning. You give it one example, and the machine learning model does its best to learn. Now, if we want to talk about that people detected, not detected thing on the security camera footage, that took about 1,400 examples of each class. Now, I cheated a little bit. Well, I wouldn't say cheated, but I edited videos together and ran them through a script to just create the frames. So it's not like I literally had to pick out, thousands of images or examples. I just edited together the videos and then automated that step. For object, the scenario with the white car, you can get away with 5 or 6 examples. And I would say that the object detection, at least the kind we have that's easy to train and use, is really good with rigid objects. So it's not going to work so well if you're expecting that object to sort of rotate in space, or you're wanting to apply a different angle to that same object from a video camera, won't work so well. You will need other examples to prove that out. So again, it really depends. I think that, depending on the use case, we can really figure out what the best approach is. And I would add that for the use cases that require deep learning, so essentially, detecting a gun in 3D space and not knowing the context ahead of time or having examples of it, we can do that too. But it does take thousands and thousands of examples to train. So this is why we really like to think about the use case, because we can really minimize that by nailing some of these lower hanging fruits really easily with not much training data. In fact, in some cases, no training data. So I think it's a holistic answer. It's not a satisfying answer because there's no one right number that sort of magically lets you answer that question. So hopefully that was sufficient, though.
Great, Aaron. The next question we have for you is, how long does it take to train one object from a time perspective? Is it 5 minutes, an hour? So let's say, for instance, that video you showed us that you edited, how long did it take you to train that, the training on that?
That's a good question. So actually editing that video together probably is what took me the most amount of time. And that was, maybe an hour. I used to be a video editor, so I can do it a little bit faster than others, but gathering the training data is actually the hardest part of all this. But the most time-consuming aspect of it would probably be so training the model itself. It ran for a couple hours on my computer. Now, I wasn't doing anything. I could go and do other work, so I don't know if that counts. But that was kind of the amount of time it took from start to finish, including that training time. However, the other use case with the car, where I was drawing a box around the car, that was like 15 minutes. So there really is kind of a broad range of time, depending on the use case again, but we can make it pretty quick. This is not a 6-month process. This is somebody sitting down at a computer, working hard, maybe for 6 to 8 hours to get the model what they need. Depending on the use case, again, it could be a lot less.
Aaron, one quick question to kind of piggyback off that. So if a client was to come to us and they have all this video, right? We take into consider their use case. Do you feel confident enough to be like, based on what you're looking for, it's going to take you about a day, it's going to take you about a week or about 2 weeks?
Yes, I think we can make that kind of rough estimate based on the use case and the data set.
Awesome.
Yeah. So I think, as you can maybe further appreciate the slide that we had earlier on, which 3 types of engines we support in Relativity, this is probably why we have a very generic engine in the object, as object detection feature in aiWARE for Relativity, because we need to know the use case. We need to know what exactly we're looking for. So that first round, that generic engine gets you finding some generic stuff you're looking for. Like I said, a car, a gun, or, waterfall, or whatever it is, right? So it's generic stuff. But again, if you want to get down into specificity, and a little bit more, then you want to contact a Veritone representative. And then we have these we have, again, a bunch of engines on our side that we can train those engines for that use case, and then import that engine back into Relativity for the customer to use.
And just, I know we're talking a lot of this in context of Relativity, but just to quickly conclude before we finish up the webinar is to say that this is aiWARE's strong suit, right? So aiWARE does this day to day. And so what we're bringing to Relativity is something that we practice all the time and it is capable of doing. So that's what we're strong at, essentially.
Yeah, thanks. Now, we have a last question here. I know we're coming close to the bottom of the hour, but this is our last question for Aaron, it looks like. So someone asked is, if I trained an engine for a specific car, let's say a Honda Accord, and it's a green Honda Accord that you just trained for, will the engine recognize the same car but in a different color, like a blue Honda Accord?
So that's a great question. Color is an interesting one because some machine learning models take it into account and others don't. Primarily, so for example, the object recognition engine that we were demoing here earlier doesn't care so much about colors. However, if you train a neural network with tons and tons of examples of a car that is one color, the neural network in the process of feedback, right? So you're saying this is a correct answer, this is not, will start to learn that the color is important. So the training data really does matter. I think having multiple colors of an engine is, of a car is going to make a difference in some cases. It really does depend. I would say that the best way to approach that, of course, if you don't have the real data set of all the different colors of a car that you're going to want to detect, you can actually do some clever things around taking images of the car and changing the colors and training it that way. Also, I think that the computer vision models that we use, which don't use deep neural networks, right? So they really are just looking at edges and shapes, which is why it works on those kind of rigid objects and not so well on things that rotate and change aspect ratio. You could probably not, color probably won't be taken into account. So that's why it matters what the use case is, right? Because there are ways to do both, and some take longer than others and probably are more intensive process than others. But if it really is just trying to detect a car regardless of the color, ironically, that might be faster than if we were trying to train it with the colors. So there's a lot. It's like I said, it's an art. It really kind of is a hands-on approach, and that's why, like Corinna said, having that one engine we have at the beginning there that just spits out tags is a great way to just tackle this without getting into any of this, and right away be able to derive value from running this process on all of your video by being able to search.
That's great, Aaron, and thank you for sharing that. And folks, again, we're going to be replaying this webinar to you. We'll be sending an email out to you guys right after this webinar. We want to thank you guys for all joining. If you do have any other questions, you want to reach out to us, you can come see us at www.veritone.com or email us at info@veritone.com. And I know some of you guys work with Corinna Soto, so you guys know where to find her, as well as Randa Akel. So they are your key contacts. And again, once again, thank you for joining us. On behalf of myself, Aaron Adele, and Corinna Soto, we want to thank you, and we'll see you next time. Bye-bye now.